In this video, we are going to discuss introductory to trigonometry. We start with right angle triangle properties. We have these two sides that are perpendicular. This side is the one that has the longest distance. It is called hypotenuse. This angle is measured using theta. It's just a Greek letter. Now, theta has to be within 0 and 90. We have three trigonometry functions, as you know. We have sine theta equal to the length of the opposite side to angle theta divided by the length of the hypotenuse side. Let's abbreviate that as this. So what is this saying is that sine is equal to the length of this side, which is basically the opposite to this angle, and it is divided by the length of the longest side, the hypotenuse. We have cosine theta equals to the length of the adjacent side. This is the side of the triangle that's adjacent to the angle theta. So this is the length. It is divided by the hypotenuse as well. And finally, we have tan theta, which is equal to the length of the opposite side divided by the adjacent side. So this also can be expressed as basically tan theta is also equal to sine of theta divided by cosine theta. And by replacing the sine theta equation up here, we will be able to drive opposite our adjacent at the end. So sine theta equals to opposite side, as you know, divided by hypotenuse. And cosine here equals to adjacent side divided by hypotenuse. We cancel out the length of the two hypotenuse sides. What is left is the opposite side, the length of the opposite side divided by the length of adjacent side. That is how we drive basically and tan theta. We can use a shortcut that is called SOH-CAH-TOA. So it is SOH-CAH and then TOA, T-O-A. Here S stands for sine of the theta. O stands for the opposite side, the length of the opposite side. H stands for the hypotenuse. Also, CK stands for cosine theta, which is equals to adjacent side divided by hypotenuse. And then finally, TOA stands for tan theta equals to O stands for the opposite, so we say opposite side divided by A, which is the adjacent. And it's just a good abbreviation just to remember, so that you don't have to really remember these equations. You can easily say, SOH-CAH-TOA. Just to keep in mind, all these properties or equations that we are talking about is applicable to a right angle triangle. If the triangle is not right angle triangle, we will learn that this sine cosine concept is not applicable. It has to be a right angle triangle, and theta has to be measured from between 0 and 90 degrees. We can use the abbreviation of SOH-CAH-TOA, so let's put SOH-CAH-TOA here. Okay, now we are going to do an example. The first example is asking us to find the 6 trigonometric functions of angle theta. This is angle theta, this is the opposite side. As you see, we have a right angle triangle, adjacent side to the angle theta, and then the hypotenuse. So we are given the opposite side here to be 8, and the adjacent side to be 6. We don't know the hypotenuse side yet. We are asked to find the 6 trigonometric functions. What are the 6? We know the sine, cosine, and tangent, and then the other 3 are cosecant, secant, and cotangent. So let's quickly see if we can figure out. At first, when you look at this, since we are missing the hypotenuse, the sine equation deals with hypotenuse, the cosine equation deals with hypotenuse. The tan equation doesn't deal hypotenuse, so we could find the value of theta and tan theta by doing that. But at first, let's just find the hypotenuse so that we can find the values of sine and cosine of the angle theta. So we're going to use Pythagorean theorem because this is a right angle triangle. We have a square plus b square equals to c square. Our c square is the longest side of the triangle, which is the hypotenuse. So c equals to square root of a square. And our a square, we call it, let's say 6 square plus b square, which is 8 square. This is equal to square root of 100 equals to 10. So our hypotenuse now is equals to hypotenuse side equals to 10. All right. Now we can get the 6 functions and trigonometry functions. So sine theta equals to the opposite side, the length of the opposite side. So angle theta is here. The opposite side is 8. So we have 8. And what is the hypotenuse divided by the hypotenuse? The length of the hypotenuse is 10. And while we add it, and sine is related to, sine theta is related to cosecant, right? Theta, which is equal to the inverse 1 over sine theta, which is equal to basically 1 over opposite side divided by hypotenuse. And this is basically hypotenuse goes at the top, length of the hypotenuse side divided by opposite side, the length of the opposite side. What is the length of the hypotenuse? It's 10. What is the length of the opposite side? It's 8. So we know 2 things now. We solve with 2 relationships. Let's do cosine. Cosine theta equals to the length of the adjacent side. Our adjacent, where is the angle? Whenever you hear adjacent, it is the length of the side that's adjacent to the angle theta. We are measuring theta, right? So that length is 6. So we have 6. We divide by the hypotenuse. This is our hypotenuse. We calculated at 10. Cosine theta is related to secant, right? And this is 1 over cosine theta, which is also 1 over adjacent, the equation of, basically we're taking the equation of cosine, adjacent side divided by hypotenuse. This gives us hypotenuse going at the top as a numerator divided by the adjacent, the value or the length of the adjacent side. Our hypotenuse side is the number that the value we calculated here, so it is 10. We divide that by the adjacent side to the angle theta is 6. Wonderful. That is another 2 relationships we solved. So the last 2 relationships, that's tan theta equals to opposite side, that is 8, divided by the adjacent side, which is 6. And in short, cotangent theta is 1 over tan theta, which is equal to adjacent side over opposite side, the length of opposite side. And this is 6 divided by our opposite side, which is 8. And basically that's it. We know our 3 basically trigonometry functions, sine, cosine, and tan theta. And then the other 3 that are related, we are asked to find 6 trigonometry functions of the following triangle. This value is 3, and this length is 4. We don't know the hypotenuse. What should we do? We do a square, Pythagorean theorem basically, b square equals to c square. This lead is c equals to square root of a square, which is let's say 3 square, and b square, which is 4 square. This is equal to square root of 25. equals to 5. So our hypotenuse here is equal to 5. All right, using SOH-CAH-TOA, we're gonna solve sine theta, cosine theta, tan theta. So what is sine theta? Sine theta is opposite our hypotenuse, the length of the opposite side. This is the angle we are talking about, sine of the angle theta. So that is 4. What is our hypotenuse? Is 5. So 4 over 5. And cosine theta is the length of the adjacent side, which is to the angle, which is 3. So we have 3 divided by the hypotenuse, which is 5. And finally, tan is equal to, tan theta equals to opposite side, which is 4, over adjacent, which is 3. These 3 relate to what? So we have sine theta is related to cosecant, CSC theta equals to 1 over sine theta, which is basically the reciprocal. So we have hypotenuse side, the length of the hypotenuse divided by the opposite side. What is the hypotenuse? Hypotenuse is 5, we calculated, divided by opposite side, which is 4. Wonderful. Cosine is related to secant. Secant theta equals to 1 over cosine theta, and this is equal to hypotenuse, the length of our hypotenuse divided by our adjacent. And that is, our hypotenuse is 5. What is our adjacent? Which is 3. And finally, our tan is related to cotangent theta, which is 1 over tan theta. This is equal to the length of the adjacent side divided by the opposite side, the length of the opposite side. And that is, what is our adjacent? Is 3. And what is our opposite side? Which is 4. Now we know we have our 3 sine, cosine, and theta, and then their corresponding relationship respectively. All right, so this is example 2. Let's see if we can do example 3 here. Right angle triangle, the value of the hypotenuse side, the length, and we have also this side. We don't know the adjacent side. So we are asked to find the 6 trigonometry functions. We start with our Pythagorean equation. C squared, A squared plus B squared equal to C squared. So we have C, which is our 13. This is our C. And this is our B. This is A that we don't know. Therefore, A equals to square root of C squared minus B squared. And this is equal to square root of 13 squared minus 5 squared, which is equal to square root of 144, which is 12. All right, so sine theta now, we know it is opposite our hypotenuse. What is the opposite side? So if the angle that we are given, if it becomes up here, always remember, if this is, let's say this is not our theta and this is theta, the same concept still applies, but this time we are focusing on the angle again. So, and what we would do is basically, this side is always the longest side, therefore it is our hypotenuse. This side now becomes the side that is adjacent to the angle, and then this side also becomes the opposite to the angle. So everything we are doing in this trigonometry introductory is more or less based on the angle theta and where that angle is located, just a general and helpful information. So sine theta equals to, the opposite side is 5 here by 13 is the hypotenuse. Sine is related to cosecant, CSC of theta, which is the reciprocal of the sine function, 1 over sine. theta, which is basically a reciprocal. So that means this value goes up, this value goes down. We have the hypotenuse, 13 divided by 5. Wonderful. And then we have cosine theta equals to the adjacent side is we calculated as a 12 divided by our hypotenuse, which is 13. Cosine of an angle is related to secant. Secant theta equals to the reciprocal or 1 over cosine theta. And that means the hypotenuse goes up. So we have 13 divided by the adjacent, which is 12. And the last group is tan theta equals to opposite side. We have 5 divided by adjacent side, which is 12. And then we have cotangent theta, which is 1 over tan. That is equal to reciprocal of this fraction, which is adjacent to 12 divided by opposite. So cotangent here equals to 12 divided by 5 on the side, the length of opposite side. Let me know if you have any questions about these introductory concepts that we are learning. Until then, have a good one.